probability concepts such as the random experiment, sample space, event probability. And also you will be able to compute some probabilities using some probability rules such as addition rule, multiplication rule, and some tree diagrams or decision trees. Right? These are the main two learning outcomes to be expected. Whether the slides are moving?
No, ma'am.
No, ma'am.
Now the slides on introduction is visible.
Yes, ma'am.
Yes, ma'am.
Now it's visible the first statement.
Yes, ma'am.
Right. So now we will look at a brief introduction on probability. This probability actually it is related in our day-to-day life. So because why we are saying that this probability is related in our day-to-day life, because most of the things that has uncertainty, right? For example, having the lectures, right? I told that the 4:30 or 4, either one of the time will be possible. So I don't know whether am I able to take at 4 o'clock exact, right? Because there are some other commitments in my career, right? So because of that, similarly, if we are taking the tomorrow, Friday, we are not sure about the Friday whether the lectures will occur, because there are some talks are going on having a strike or harta, right? So we can't sure whether the tomorrow you will have the lectures or not. Right? So this kind of uncertainty occurs in our day-to-day life. And also it is very rare to have a perfect information regarding various inputs to a decision. So if you want to make a decision, perfect decision, if you want to make, our input also have the perfect information. But it's very rare situation to get the perfect information because of the uncertainty. So the probability theory is used to measure the degree of uncertainty involved. So we can measure to what extent we are having the uncertainty of deciding the particular information or to deciding the particular decision making, right? So here the probability is important. It measures the degree of uncertainty. And also this probability theory is very important to the statistical inference. This statistical inference provides the decision maker a body of methods which help decision making under uncertainty, right? So in few weeks, we will learn about decision making, statistical inference. So there we are making the decision based on the uncertainty, right? So there we are giving some space for uncertainty, right? So we cannot say that our decision is 100% right, right? We are saying that only 95% our decision is right. Only 90% our decision is right, right? So this 10% or 5% we are giving for uncertainty, right? That we will learn about under the hypothesis testing and the estimation of parameters. This uncertainty we are accounting for some space, right? So there this probability theory is very important. Now the next slide, are you able to see?
Yes, ma'am.
Right, okay. So now here we are looking at a simple example where this probability theory we are using in a workplace, right? So here it's related to the marketing study, marketing related study. They are analyzing the survey result of the intention to purchase. right? They are planning this M&R Electronics. They are planning to introduce a big television screen. And so before introducing the television screen, they are the customers are ready to buy the big TV screen, right? So before starting their planning their business, now they are taking a survey with the potential customers, right? So they are asking those potential customers whether they have any intention to purchase a big screen television somewhere in the next 12 months time, right? And also they are asking, in addition to that information, they are asking whether the particular plasma screen they will buy or not, and also whether they are satisfied with their purchase of a big screen, right? These two types of survey they are making 12 months ago, and after the 12 months they are making the survey. So by using these results of this survey, they can plan a new marketing strategy. This will enhance their better target of those households to purchase multiple or more expensive products. Whether this particular kind of household, whether they can target them to introduce very expensive type of electronic items, and also how much of they have to produce and what type of screen they have to produce. So much of things they can find out by using this survey study. So under this survey study, what type of question they are going to answer using the customers' answers? Mainly here they are calculating the probabilities, right? Suppose for example, what is the probability that a household is planning to purchase a big screen television in the next year? So this is before starting their sales, the first short survey, they are calculating this probability using the results of the first survey study, right? So what is the probability that a household will actually purchase a big screen television? So here they are looking at the chances of buying a big screen television. So these kind of probabilities they can calculate based on the first survey. Then in addition to that survey studies, here there are some probabilities. So also they are looking at to design about a new marketing strategy regarding introducing such expensive kind of electronics, right? So what is the probability that the household that purchase a big screen television will satisfied with the purchase, right? So whether with a plasma screen, whether they will also purchase a DVR, right? Such kind of probability also they can calculate. So this is a simple example where we are using the probability in the workplace, right? So now we are coming to the concept of probability. What is probability? A probability is a numerical value. Nothing, right? That's a numerical value, right? This numerical value represents the chance or likelihood or possibility a particular event will occur. These three terms, chance, likelihood, possibility or probability, all these are interchangeably used, right, for the probability. The probability we can ask the chance, we can say about likelihood, sorry, or we can talk about the possibility, right? Now we are saying that what is the chance of getting a train today, raining today, right? What is the chance of expecting a hartal tomorrow or day after tomorrow? What is the chance of getting a continuous strike from the 11th onwards. What is the chance of resigning the president, the current president or prime minister, right? So all are depending in the chance or likelihood or probability. All are making the interchangeable same meaning. So just a numerical measure, right? We can express this numerical measure in a decimal format or in the percentage, 50% of chance getting a hatta day after tomorrow. Okay? So 60% of a chance getting a gas today, right? All these are depending on the chance, right? So, but to get the proper understanding on the probability, it will start with the random experiment. So, right, to how we can calculate the probability, so we can talk about or we can look at the concept of random experiment. So now we will move to what is random experiment. This random experiment is an experiment. Experiment means we are doing some activities and observing what will happen because of that activity. Right? So in that case, the random experiment means before doing the activity, we know what are the outcomes of that activity. Right? Before doing the activity, we know all the possible outcomes of that activity. But we are not able to predict the outcome with certainty of any individual experimentation in advance. Very simple example, user-friendly example for the random experiment, tossing a coin. Right? So when tossing a coin, we know that it may be head or it may be tail. Only two possible outcomes are there. But in advance, we are able to list all those possible outcomes we can get by tossing a coin. But before doing the experiment, we don't know what will be the outcome. Whether we are going to get the tail or we are going to get the head. Exactly, we can't say that. This is the meaning of the random experiment. So, an experiment is called a random experiment if it's such that all the possible results, the results is called as outcomes, are known, but it is impossible to predict the outcome with certainty of any individual experimentation in advance. Before doing any individual experiment in advance, we cannot say this will occur exact. We cannot say this outcome will occur exact. Right? Suppose, for example, marks of a statistics exam. Right? There is a possibility of getting the marks from 0 to 100. Right? There is a possibility of getting marks from 0 to 100. But once your final exam papers marked, only we can say that what is your exact marks for the statistical exam. Right? After marking your paper, then only we know that what is your exact marks. Until that, we can't say that what is your exam mark. But out from 0 to 100, one of the point will be your marks. Right? So some of the examples are flipping a coin or tossing a coin. The outcomes are head and tail. Marks of exam, it may be 0 to 100. Assembly time, right? For we are manufacturing chair or we are manufacturing a certain product, right? So it takes the times greater than 0, but we don't know what will be the exact time. From product to product, the same product to product also, it will change by 1 minute or 2 minutes or 1 second, right? It is depending on the efficiency of the workers. It is depending on some other technical issues. So a lot of the facts will affect the fixing the time of a certain product. So it may vary from more than 0 seconds. Birth of a child, right? We can't say that it will be male or female. Even some nowadays, in 5 months' time, by the scan, we can say that. Before that, we can't say that whether it's a male or female child. Right? So flipping a coin is an experiment. The previous outcomes. In advance, we know all the possible outcomes. Exam marks is a random experiment. We know the possibility of the marks the student can get. Assembly time of a product, it may be greater than 0 seconds. Then birth of a child, it may be male or female. So to determine the probability of occurrence of a certain outcome, it is needed to define the possible outcomes first. So if we want to find out what is the probability of getting a head, what is the probability of getting a tail, what is the probability of getting a mark 79, what will be the possibility of the assembly time be 1.2 seconds, what will be the possibility of getting a female child. Right? So to calculate this occurrence of certain outcomes, first we have to define all the possible outcomes. Right? So now we are looking at the sample space. So to determine the possible outcomes, we have to build an exhaustive list of all possible outcomes. It's include, that means exhaustive means that list include all the possible outcomes. For example, the marks of a student. We are saying that 1 to 100. But there is a possibility of getting 0 marks. Right? So if we are not including the 0 marks in our list, that will not exhaustive list. Right? So if we are including 0 to 100 each and every point in the list, then that is called exhaustive. So exhaustive list means it includes all possible outcomes. And also when we are building a list of possible outcomes, all the possible outcomes must be mutually exclusive. So what is the meaning of mutually exclusive? 2 outcomes cannot occur at the same time. 2 outcomes cannot occur at the same time. Right? For example, now we are selecting a particular student. That student can only mark 65. Right? He can't have a mark 65 or 70 or 40 or 70. Only one of the marks from 0 to 100 he or she can have. Right? Similarly, tossing a coin. Only there are 2 possible outcomes, head and tail. So when we are tossing a coin, we can get either head or tail. We cannot get both head and tail at the same time. Right? So this type of outcomes is called mutually exclusive. So make sure that the listed outcomes are mutually exclusive. So that means no 2 outcomes can occur at the same time. So based on this one, now we are defining the next definition. First we will define the probability. Now we are defining the term sample space. So a sample space of a random experiment is a list of all possible outcomes of the experiment. Sample space of a random experiment is a list of all possible outcomes, not few outcomes, all possible outcomes of the experiment. And also, these outcomes must be mutually exclusive and exhaustive. If this is the case, then that will be the sample space. So, the sample space is very important to find out the probabilities of the outcomes. Right? Then the sample space can be divided into 2 cases, the discrete sample space and the infinite sample space. Now we will look at one by one. Discrete sample space. What is the meaning of discrete? If there are finite of innumerable outcomes in a sample space, then it is known as a discrete sample space. Now, for example, tossing a coin. So, how many possible outcomes? Head and two. So, this is called as a finite discrete sample space. Right? Then when we are tossing or rolling a die, six-sided die, rolling a six-sided die. So there are 6 possible outcomes. It may be 1 or 2 or 3 or 4 or 5 or 6. So this is also discrete sample space. Then the continuous sample, discrete or infinite sample space or continuous sample space. Both are same. So under this case, there are infinite number of outcomes will be in the sample space, and also we are not able to count. We are not able to count. For example, assembly time of a particular product. So only we know that it will take greater than 0 seconds. Right? Assembly time of a product, it may be greater than 0 seconds. Right? So it may be 30 seconds or 15 seconds or 1.5 seconds or 20 seconds or 75 seconds. Right? So just we know that the time is greater than 0. So if we are representing our sample space as a t, where t greater than 0, then there are infinite number of possible outcomes. It may be 2 minutes or 2.5 minutes or 150 seconds or 180 seconds. In such manner, we can say the sample space. So this is called as a continuous sample space. There are infinitely many outcomes in a sample space, then it is known as a continuous sample space. So this is the difference between the discrete and the continuous. So for the discrete, the possible outcomes are countable, but for the infinite number of outcomes, that is undiscrete, here the numbers cannot be counted. That is the infinite number, right? Right. Now we are coming with the event, another terminology often we will use in the probability or even in the probability distribution event. The event, first we are taking the simple event. Event can be classified as a simple event or compound event. Here we are taking the simple event. All the simple events are the outcomes of the random experiment. All the simple events are the outcome of random experiments. These outcomes cannot be further decomposed into constituent of outcomes. That means we cannot further join this 1 or 2 outcomes as a one outcome. That is the main thing as a simple event. So the simple event, outcomes called simple events, which cannot be further decomposed into constituent outcomes. Then event. So an event may be the collection of 1 or more simple events. Right? If you know the simple events from the experiment, then by combining 1 or 2 more simple events, then we can form the outcome. Right? Now we are coming for example, random experiment. So here throwing a die. There is a sample space 1, 2, 3, 4, 5, 6. Right? Event A, getting an even number. It may be 2, 4, 6. Event B, getting a number which is perfect square, 1 and 4. So now we are looking at this 1, 2, 3, 4, 5, 6 are the simple events, right? Because all possible outcomes of an experiment are simple events because they cannot further decompose. But now we are defining event A, getting an even number. From these simple events, it may be 2 or it may be 4 or it may be 6. So now we are listing A as 2, 4, 6. So it consists of more than one simple event. So it is called a simple event. Similarly, B, getting a number which is perfect square. 1 is the perfect square and 2 is the perfect square. Right? Perfect square means a number that is multiplied with itself. A number that is multiplied with itself. 2 by 2, 3 into 3, 4 into 4, all are the perfect square. Right? So then from these 6 numbers, 1 and 4 are the perfect square. So this is called as a event. Right? Now we are looking at what are the requirements we can look at for when calculating the probability for a simple event or for an event. Right? Now we say that there is a sample space. Usually the sample space denoted by S. It consists of K simple possibilities or outcomes that is denoted by O1, O2 up to OK. Outcome 1, outcome 2. All these outcomes are exhaustive of a probability space and the outcomes of the experiment, right? Then in the probabilities assigned to the outcome, initially for whatever event we are calculating the probability, sorry for the disturbance, right? Now we will continue. So to find out the probability of the event, we have to start with the random experiment and we have to look at the outcomes. Then for each and every outcome, we have to assign the probability. By using these probabilities, we can calculate for whatever event we are defining, we can calculate the probability. But how we are going to assign the probabilities for the outcomes? Right? How we are assign the probabilities to the outcomes? Right? So before assigning these outcomes, for the assigning the probabilities for the outcomes, there are some requirements. That requirements should be satisfied when we are assigning the probabilities to the outcomes, even for the event also. First one, for the probability of any outcome should be between 0 to 1, including 0 and 1. Right? That is denoted by 0 less than or equal to probability of outcome I less than or equal to 1 for each child. For any event, the probability falls in between 0 to 1, including 0 and 1. Second one, in the sum of the probabilities of all the outcomes equals 1. Sum of the probabilities of all the outcomes equal 1. PO1 plus PO2 up to POK, because there are K outcomes equals 1. For example, when we are tossing a coin, how many outcomes? There are 2 possible outcomes, head and tail. So then when we are adding the probability of getting head plus probability of getting tail must be 1. Right? And also the probability of head less than 1 greater than, including 0 or greater than 0, 1 or less than 1. Similarly, probability of head also greater than or equal to 0 or less than or equal to 1. These 2 are the requirements that must be considered when we are assigning the probabilities. Right? So in the notation form, in between 0 to 1 denoted by this one, for sum of all the probabilities, already this notation introduced to you. So sum is equal to I is equal to 1 to n k, probability of O I equals 1. Right? Approaches to assigning probabilities. Right? So there are 3 methods we can use to assign a probability. right? There are three methods we can use to assign a probability for any outcome, right? Outcome means the results we obtain from a random experiment. Here we are using the notation OI, that is ith outcome, right? So one is the classical approach. The classical approach is the very simplest method. Here we are making some assumptions. The most assumptions under the classical approach, we are saying that each and every outcome has equal chance to occur. Now we are taking a coin, and if this coin is fair coin, that means there is no bias in the coin, right? Then we can say that the probability of getting tail equals the probability of getting tail. Both outcomes have equal chance to occur, right? This is named as, this kind of approach is named as classical approach, right? So we are making certain assumptions such as equally likely or independence about the situation. Then relative frequency approach. Second approach is relative frequency approach. This is also easiest method, but here we can look at the historical data or the experimental information we have to look at. Assigning probabilities based on the experimentation or historical data. Now we are saying that the coin, the same thing, right? Coin, that is a biased, little bit biased, and we can't sure that each and every outcome, obtaining head and obtaining tail, have equal chances. We are not sure about it. So what we are saying that 1,000 times we are tossing a coin. Right? 1,000 times under the same situation or under the same condition, we are tossing a coin 1,000 times or 2,000 times. And then among these 1,000 or 2,000 times, we observe that how many times head occurred and how many times tail occurred. By using those information, we can assign the probability for getting tail and assign the probability for getting tail. This kind of approach is called a relative frequency approach. Mostly, we are using this classical approach and the relative frequency approach to calculate the probabilities. Right? This third approach is a subjective approach. Subjective approach is a difficult one, and also we need more experience. This subjective approach is depending on the assigner's knowledge and the previous historical knowledge also we need. That is called as a subjective approach. Right? Assigning probability is based on the assigner's judgment. Now we coming one by one, classical approach. Right? So in the classical approach, we say that there are n possible outcomes. Right? And then we can say that so as a classical approach, we say that each and every outcome has equal chance, and there are n possible outcomes. Then the probability will be 1 over n. Right? So now simple example, tossing a coin. So it's under the classical approach, there are two outcomes. So accordingly, each and every outcome has equal chance, that is 1 over 2 and 1 over 2. Right? Similarly, the rolling die, there are 6 possible outcomes. So there are each and every sample point has a 1 over 6 chance of occurring. Getting 1 is 1 over 6, getting 2 is 1 over 6. Similarly, getting 6 is 1 over 6. Then relative frequency approach. So simple example here we are taking. This is a computer shop. They want to find out per day, if we want 0 computers, how many days occur? What is the probability of getting 0 sales in a week? What is the probability of getting 1 in a week or in a day? What is the probability of getting 2 sales of 2 computers in a day? What is the probability of getting 3 sales of computers in a day? What is the probability of getting 4 computers sold in a day? Right? So to calculate those probabilities, we are looking at these sales over the 30 days. For a 1 month, we are observing. And then we are counting How many days? 0 desktop solved, only 1 day. So there are 30 days are there. So on 1 day we will get 1. So the probability is 1 over 30. That is 0.03. Right? Similarly, the probability of getting 2. How many days we solve 2 computers? 10 days. Right? So out of 30, 10 days we will solve 10 computers. So that means there is a 0.33 of chance to getting 2 sales of computers in a selected day. Right? And then what these numbers tell? So that is an interpretation of a probability. Now we are taking this 40%. So it is 3 days. They are having 3 computers in the 12 days. Out of 30 days, 12 days they have 3 computers sold. So from that one, the probability of selling 3 computers in a particular day. Yes. Oh, 1 minute. Right. So there is a 40% chance bits and bytes will sell 3 desktop on any given day. That is interpretation also very important, right? So now here a simple example I told that for 0.40, what is this means? This is the means, right? Yes, the chance indicates the certain measure of the uncertainty. Only 40% only there is a chance. For 60% uncertainty for a particular day, the 3 computers sold. Right? Now here a very simple example here we are taking. Right? You first read the example carefully. There are 5 top selling cars in a country are shown below. Right? There are 5 brands, A, B, C, D are the 5 brands of the car. Right? And they are looking at this, how many times this car sold in a particular country for a certain period. Right? So how they are measuring this one, they are taking the registration form. Right? 200,000 cars registration form they are taking, and from those they are observed for each and every registration form what type of car they put registered. Right? So from that they found that for car A, brand A, 50,000 registration forms have brand A car. 44,000 forms have brand B car. 40,000 registration forms has brand C car. Similarly, these 5 brand cars are how many times they occurred in the registration forms. Right? So, the previous examples also example of a relative frequency approach. Here also we are going to assign the probability using the relative frequency approach. So how we can assign the relative frequency approach by using, first we have to find out the sample, we have to create the sample space for the random experiment. So here what is the random experiment? Observing the registration form, observing what brand car appeared in the registration form, observing what brand car appeared in the registration form. So based on the given information, there are 5 brand cars have possibility to appear in the registration form. So according to the given information, now here I will write the answer. You also copy down this answer, right? So now our sample space. Usually the sample space is denoted by S. For first question, right answer, we have put in the set notation. What are the brands availability? A, B, C, D, E. This is our sample space. There are 5 possible outcomes are there. Once we go through the application form, then only we can identify which car, which brand of the car occurred. Right? So now there are 5 simple events are there. So now here we cannot apply the classical approach because we don't know. We can't say that these are equally occurred, equally likely occurred. So here we are going to use the relative frequency approach. Now we say that there are 200,000 total number of applications we observe, right? So based on that one, probability of A is equal to, this is the probability of a simple event A, or outcome A, that is equal to, how many times A occurred? 50,000 over 200,000. Total number of observations we observe, 200,000. So that is equal to, if you want to give it the decimal point, that is 0.25. Okay. Similarly, probability of B. So what is this one is the 25% chance that the brand car A appeared in the registration form. Only 25 times chance the brand A appeared in the registration form. Right? So similarly, probability of B, that is equal to how many times B occurred? 44,000. 44,000 divided by 200,000. This is equal to 0.2. Similarly, probability of probability of C is equal to 40,000 over 200,000. You write expanded step, but I write the answer only 0.2 to check this answer, right? Then probability of D is equal to 34,000 over 200,000, that is 0.17. And probability of E is equal to 32,000 over 200,000, that is 0.16. And also, now we look at these, all the probabilities are less than 1 and greater than 0. And also, when you are adding all these 5 probabilities, that is equal to 1. Right? So, all the requirements of the probabilities also satisfied with this example. Right? Right. So, this is the method of applying the relative frequency approach to calculate the probabilities. Okay. Then subjective approach. In this approach, we define the probability as the degree of belief that we hold in the occurrence of an event. There is no any, this is not an objective calculation, right? So based on the assigner's experience, based on the assigner's belief, based on the past experience, right? The probability will be assigned. This is a judgmental assignment, right? Weather forecasting, right? The weather forecasting also, nowadays, the weather forecasting part, the hybrid method, both subjective and objective method are used, but in the very earlier period, we only use the subjective approach to make the weather forecasting, right? So main 2 methods you have to know to assign the probabilities. One is the classical approach and the other one is the relative frequency approach. Classical approach, we are making some assumptions, that is equally likely occurred or independent, such kind of assumptions we make. Under the relative frequency approach, we are observing or we are repeating the experiment several times, and from that we are making the calculations of the probabilities for the outcomes of the experiment. Right? Right. Now we looked at how we can calculate the probabilities for the outcomes for the simple event, right? So based on the experiment or based on the random experiment, we are assigning the probability. Now, once we assign the probabilities for the outcomes, now we look at how we can calculate the probabilities for the event. Right? Event is made of 2 or more simple events, right? Event is made of 2 or more simple events. So in that case, because all the simple events are mutually exclusive, all the simple events are mutually exclusive, just we have to add what are the simple events is used to make the event. All those simple probabilities will be added together. That will be the probability of an event. Example, we are looking at the experiment rolling a die. We say that it's a fair die, right? So the sample space is, when rolling a 6-sided die, the sample space is 1, 2, 3, 4, 5, 6, right? Then the probabilities of those simple events are same, because we are saying that it is a fair die. So each and every outcome has equal chance to occur. So P1 equals P2 up to P6 equals 1 over 6. Now we are getting the event, we are defining the event A as getting an even number. Right? Getting an even number when we are rolling a die. So now we list down what are the possible outcomes for the event A. Here from this sample space, we say that 2, 4, 6 are the possible outcomes. Right? So probability of getting an even number is probability of A. This is the way of writing. And this A is made of 2, 4, 6. So probability of 2 plus probability of 4 plus probability of 6. Then by looking at these 6 probabilities, probability of 2 is 1 over 6 plus 1 over 6 plus 1 over 6. That is 3 over 6, that is half. Right? So this is the way of calculating the probability of an event. So if you want to calculate the probability of an event, first you think about the appropriate random experiment and what are the possible outcomes we can get through the random experiment, and what are the probabilities for each and every outcome. By using those probabilities we obtain for each and every outcome, then we can calculate the probabilities for the particular event by summing all the related probabilities of the outcomes. Right? Then another events we can make by using the combination of events. Right? We can make the combination of events by using some logical inclusions. Right? There are various methods to determine the probabilities of the events that result from the combining other events in various ways, right? Now first we make the event using the simple events by combining the simple events. Now we are looking at in another form of combining events using the various methods, right? Now we are looking at what are the types of combinations and the relationships between the events. First one is the complement of an event, right? So complement of an event means that event not occur. Complement of an event is the event not occurred. Right? Intersection of events, the common outcomes which are occurred in both events. The common outcomes which are occurred in the both events. Union of the events, either outcomes of the event or the outcomes of the other event, or all the outcomes of the two events can occur. These are the combinations we are going to look at. Mostly these three combinations we are looking at to calculate the probabilities. So for example, we are taking event A and B are the two events. These two events are formulated with the outcomes of the experiments, right? Now we are looking at A or B. That means A occur or B occur or both. Then probability of A or B, probability of A occur or B occur, both. Similarly, A and B, both A and B occur. A complement, A does not occur. A given B, this is another conditional event we are saying that. That is, if B occurred, then what is the, how A will occur? If B occurred, how A will occur? So that is the, then when we are looking at the probability of A given B, this is called as a conditional event. Now this vertical line we are reading as a given, A given B. So probability of A occurs given that B has occurred, right? Now example, we are taking the simple example to get understanding of the combination of events. The number of spots turning up when a six-sided die is tossed or observed. Consider the following events. A, the number observed is at most 2. right? B, the number observed is an even number. C, the number 4 turns up. Answer the following questions. Right? Now I am giving 10 minutes time. You take a white paper and you write the answers. Right? Now the time is 5:26. So 5:36, I will come back and check your answers. Right? So now for the 10 minutes time, you can answer this question and ready to check your answers, right? Right. So now it is very a simple example. Only it's a six-side die is tossed, and they define the events A. The number of observed is at most 2. The number observed is an even number. The number 4 turns up. Right? So any student, can you answer, define the sample space for this experiment and assign the probabilities to the simple events? What will be the sample space? What will be the sample space? Right? It's a very simple six-side die. So when we are turning up a die, it may be 1, 2, 3, 4, 5, 6. Right? Right, very good. Right? So the sample space is S is equal to 1, 2, 3, 4, 5, 6. Then what are the probabilities? Put in the text what are the probabilities and what is the method you use to assign the probabilities. The chat box write answers. Here we know that we don't have any further information, additional information. So here we can take that is what is 6? When we are assigning the probability, you know that probability is in between 0 to 1, and when we are adding all the outcomes, probabilities of outcomes should be 1. What do you mean by 6? Right? So using the classical approach, right? First, when you are writing the answers, logically you have to know that whether you are writing the right answer or not. Otherwise, don't write it. What is 6 and 1? Right? So now 44, 33. What are the things you are writing? Are you in the class or you are not in the class? Listening the class or not? So based on the classical approach, we say that each and every event has equal chance. So that is probability of getting 1 equals probability of getting 2 equals probability of getting 3 equals probability of getting 4 equals probability of getting 5 equals probability of getting 6. What is the probability for each and every one? 1 over 6. Right? So this is the answer for the first part. Then find PA. What is PA? A is the number observed is at most 2. So first we have to list out what are the possible outcomes for A. So A is equal, A may be Right. So now we have to list out what are the possible outcomes for A. What is A? A is the number observed is at most 2. The maximum observed number is at most 2. So A may be 1 and 2. Right? 1 and 2. So what is probability of A? That is probability of 1 plus probability of 2. So that is equal to probability of 1, already we have 1 over 6 plus 1 over 6, that is 1 over 3. Right? Right. Now, if you want to note it, I am going to erase this one to answer the next question.
Olivia.
Right. Next one, P, probability of A complement. Probability of A complement. Now we know that A is one and two. So A complement the events which are not in A. A complements means events which are not in A. So in the sample space we know that S is equal to 1, 2, 3, 4, 5, 6. Right? So A complement events which are not A, then those are 3, 4, 5, 6. So probability of A complement, that is probability of 3 plus probability of 4 plus probability of 5 plus probability of 6. So now for each and every outcome has equal chance. So 1 over 6 plus 1 over 6 plus 1 over 6 plus 1 over 6. That is 4 over 6. That is 2 over 3. Right? Then are events A and C mutually exclusive? Are events A and C mutually exclusive? Now we know that what is C. C is defined by the number 4 turns up. It is defined by the number 4 turns up. So the event C have only the one element 4. Right? So A has only 1 and 2. So now we can say that whether A and C are mutually exclusive or not. You put the answer in the yes or no. You put in chat box and put the reason why. If yes, why? If no, why? Write the answer in the chat box. what is the meaning of mutually exclusive? Mutually exclusive means the two events does not occur at the same time. The two events does not occur at the same time. Now we are taking A, 1 and 2, and C, 4. So there is no possibility of occurring these two events at the same time because there is no any common element in the two events A and C. So as A and C, there is no any common element in A and C. These two events does not occur at the same time, right? You write the answer, right? I dictate that one, only write the answer you, right? As there is no common elements, as there is no common outcomes, right? As there is no common outcomes in both A and C, both events does not occur at the same time. Therefore, A and C are mutually exclusive events. Right? A and C are mutually exclusive. You have to write the event C, and also you have to write as A and C has no common element. These two events do not occur at the same time. Therefore, A and C are mutually exclusive events. A and C are mutually exclusive, right? Both A and C are mutually exclusive. Okay? Find probability of A or C. Right? Now here we know that A and C. So now first you identify what are the elements belongs to A or C. So we are taking A. A or C means the elements either the elements in A or C or both. In A 1 and 2, 1 comma 2, and in C 4. So these are the three possible outcomes which are belonging to A or C. Then so now we know the elements for A or C. So now we can calculate the probability. So probability of A or C equals all this event A or C is made up of these three simple events or outcomes 1, 2, 4. So we can add all those probability. So because all these outcomes are mutually exclusive, probability of 1, probability of 2, plus probability of 4. We know that probability of 1 over 6, plus 1 over 6, plus 1 over 6, that is 2 over 3 over 6 halves. Right? Then find A and B. So probability of A and B. So before finding the probability, first we have to find out what are the possible outcomes for A and B. So based on the definition of A and B, that means the common elements for both A and B. So in A, you have 1 and 2. B, what is B? B, the number observed is an even number. So from this one, we can write the elements for B. Even number. So from our sample space, the even numbers are 2, 4, 6. 2, 4, 6. When we are looking at A and B, what is the common element? The common element is 2. So A and B is 2. Therefore, probability of A and B is B is equal to 1 element 2. The probability of getting 2 is 1 over 6. This is the method of calculating the probability from the random experiment. Calculating the probability of events from the random experiment. Right? So take a 2 minutes time, and if you want, you can note these probabilities. This is exercise. I'm leaving as a homework. Then you can read the exercise and do it, right? How now here we did the previous example. Similarly, here a little bit, when you are reading this one clearly, then you can get the idea. Here you have to define the random experiment and list the simple events in the random experiment. Right. So an investor has asked his stockbroker to rate 3 stocks, A, B, and C. There are 3 types of stocks are there, and list them in the order in which she would recommend them. Right? So the rating is lowest to highest rating. Right? It may be highest rating or lowest rating. She would recommend, consider the following events. Then there are 3 events they are defining. L, stock A does not receive the lowest rating. Stock B does not receive the lowest rating. Stock C receives the highest rating. Based on this experiment and the events, there are some questions listed out. Right? The first question, define the random experiment and list the simple events in the sample space. So first you have to identify what is the random experiment. So here the random experiment is ratings of the stocks. Rating of the stocks. Right? So it may be highest or lowest or in between highest and the lowest. So for example, one of the rating, first A is the highest rating, the next highest B, then C is the lowest. This is one of the choice. The second choice may be B is the highest rating, A is the second highest rating, and C is the lowest rating. Similarly, you have to find out how many possibilities. So experiment rates of 3 stocks A, B, C. Then you have to, at a time, these 3 stocks you have to rate it, right? What are the possibilities of rating? For example, I can say that one possible outcome. If I am saying one possible outcome is the sample space, our one of the possible outcome A, B, C. Right? So this means A receives the highest rating, B is the second highest, and C is the lowest rating. So the next outcome may be B, A, C. This means B receives the highest rating, A is the second highest, and C is the next lowest rating. Similarly, you have to find out the possibilities. Right? Only the events. You don't need to write the probabilities. Right? Then define the list the simple events. So list the simple events in each of. So from this sample space, you have to identify what is L, what is M, what is N. And also from this L, M and N, then here combined events, right? So this L, M, N are made from these simple events. Then these three events are made from this combined events, right? So L, O, N. So by using the possible outcomes from LMN, you have to find out LON, LNM, and M combined. Then you have to find out whether LMN, is there any pair of mutually exclusive events among LM and N, or is there any pair exclusive events among LM and N? Right? So these are the approach you have to follow to find out the right? Here, this is also another exercise. As how you are doing the first previous one, similarly, this exercise also you have to do, right? So when you are coming to the next class, you have to bring us those two exercises, right? Now we are coming for the next concept, conditional probability. Conditional probability means there are two events related to this conditional probability, right? If the one event occurs, then what is the probability of occurring the second event? Already one event has happened, then what is the probability of getting the second event? So in the conditional probability, the partial knowledge about the outcome of an experiment is known, is called conditional probability, right? We use the notation for conditional probability, probability of A given B. That means how this is read, the conditional probability that event A occurs given that B has occurred, right? In this separation, this is the event occurred first. Then the occurrence of A depending on the occurrence of B. So B occurred, if B occurred, then how A can occur, right? This is the wording. Then when we are writing this one, probability of A given B is defined by probability of A and B divided by probability of B. The partial knowledge is contained in the condition. So partial knowledge is coming from B, right? Example. Right. So now you look at read this example clearly. There are two types of events here we are taking. This table tells about the probabilities, right? Compares the mutual fund performance against the ranking of the school where the fund manager earned their MBA, right? So it is related to the education and the performance of the mutual fund, right? So now in the education there are two cases. A1 fund manager graduated from the top 20 MBA program, and A2 fund manager did not graduate from a top 20 MBA program. These two are related, right? This row indicates the performance of the mutual fund if A is graduated from the top 20 program, right? This is the performance of the probability of performing the mutual fund if A2 is not graduated from a top 20 MBA program. Right? Then B1, fund outperforms the market. This denotes the fund outperforms the market. B2 not outperform the market. Right? So, what is the probability that fund will outperform the market given that the manager graduated from the top 20 program? Right? If the manager graduated from a top 20 MBA program, then what is the probability that a fund will outperform the market? So, it is a conditional probability that indicates the partial knowledge from this graduation from a top 20 MBA program. Right? So now we will look at how we can translate this one into the statistical formation. Now we have to calculate the probability. All the probabilities are given, right? Probability of fund will outperform the market. So what's it denoted by B1? Fund outperforms the market. So probability of B1. Given that the manager graduated from a top 20 MBA program. So the manager graduated, that is denoted by A1. So this is equal to probability of, based on the definition, probability of B1 intersection A1 given that probability of A1. In the previous slide, you have the formula, right? How we can calculate the conditional probability, right? So probability of B1 intersection A1. This row indicates A1. This column indicates B1. And intersection of B1 A1 this. Right? So that is 0.11 divided by probability of A1. So A1 either 0.11 or 0.29. So that is 0.11 plus 0.29. That is probability of A1 means the fund manager graduated from a top 20 MBA program, right? The fund manager probability that the fund manager graduated from a top 20 MBA program. So it may be 0.11 or 0.29. Right? So that is equal to 0.11 over 0.40. That is 11 over 40. That is 0.275. That is 0.275. Right? So this is the method of calculating the conditional probability. So if the manager is, what does this probability means? If the manager graduated from a top 20 program, then the probability of fund outperforming the market is only 0.275, right? 2.75%. The fund will outperform the market. That means the fund will performing very well, right? If the manager graduated from a top 20 MBA program. If the manager does not graduated from a top 20 program, then you have to use these probabilities, right? So this is the intersection probability, and this probability of A1 is called the marginal probability, right? Probability of A1 is called the marginal probability. These are the things so far we looked at: probability, random experiment, sample space, event, approaches to assign probabilities to the outcomes, computing probabilities, computing probability of combination of events. The combination of events we looked at: complement, union, intersection, and the condition. Then the independent and the dependent events. If two events A and B are said to be independent, if the performance of A does not affect, or the occurrence of A does not affect by, will not be affected by B, or the occurrence of B will not be affected by A. That means probability of A given B equals A, or probability of B given A equals B. So if you are being asked to show that if two events A and B are independent, then you have to show either one of the results. You have to show that. That means probability of A given B is A. That means the B does not affect the occurrence of A. Or probability of B given A is equal to B, probability of B. If these two are not equal, then these events are dependent. So if the occurrence of one event does not change the likelihood of the occurrence of the other event, the two events are independent, right? But you have to remember that these two events, independent events and the mutually exclusive events are not the same, right? Mutually exclusive events means the two events does not occur at the same time. The two events does not occur at the same time. But independent events means the occurrence of one event does not affect the occurrence of the other event. So you have to clear with these two concepts. These two concepts are entirely different, right? Then the marginal probabilities. Marginal probabilities are computed by adding across rows and down the columns. That is, they calculated in the margins of the table, right? For example, the previous example, outperforming the market and not graduated or graduated from a top 20 program. If we are adding these two probabilities that give probability of A1, this is a marginal probability. Adding this row, you will get 0.60. This is one of the marginal probability. When we are adding two marginal probabilities, obtain row-wise, that is equal to 1. So this is row-wise margins. These are the column-wise margins. By adding these two probabilities, down column 0.17, then we are adding these two probabilities 0.8. So this is probability of B1 and this is probability of B2. This is probability of A1, this is probability of A2. So when adding the marginal probabilities, either column or either row, then we will get the 1. Right? So now, what is the probability? A fund manager is not from a top school. The fund manager is not from a top school. So we have to get the probability of A2 because A2 denotes the manager. He did not graduated from a top 20 MBA program. So that is probability of A2. That is 0.60, right? What is the probability? A fund outperforms the market. So B1 denotes outperforming the market, B2 denotes fund not outperforming the market. So for this case, this is the probability of B1, that is 0.17. Right? Both margins must add equal to 1. Column-wise, this is the column-wise margins, that is equal to 1. This is row margins, that is also equal to 1. From the previous example, probability of B1 given A1, this is already been calculated, 0.275, right? the marginal probability of B1 from the previous table. The marginal probability of B1 is 0.17. So now, probability of B1 given A1 is not equal to probability of B1. Right? So, we can say that B1 and A1 are not independent events. Right? So, the occurrence of B1 affected by A1. The occurrence of B1 is affected by the occurrence of A1. Right? This is I am leaving as exercise. Right? Similarly, how we did in the fund outperforming, here only the frequencies are there. Right? From that, you have to calculate the probability. In the previous example, already the probability given to you in each and every cell. Here, not the probabilities. What are the number of people occurred in each and every one. From this, you have to calculate the related probabilities, and then you have to answer these questions. Right? This is another exercise. Right. So now I am stopping the class. So the Friday we will start with the probability rules. So there are 4 or 5 exercises left as homework. So when you are coming to the next class, you have to bring the answers. First we check the answers, and then we will move. If you are not bringing the answers, then only one question I will discuss. Then others I will leave it as a without checking or without discussion, I leave it. Right? So now I am stop my sharing. If you want to ask, clarify anything from today's lecture, if you have any doubt, then you can clarify now. So class rep, are you there, class rep? Danishan? So tomorrow night, you let the rep, tomorrow night he has to confirm my time, right? So if he is confirming the time, then I will let him win the Friday class. What is your time for the Friday class, right? So now I am ending in my meeting.